Hello, today I'd like to talk about the correlation coefficient. Now, the correlation coefficient was first introduced by Sir Francis Galton in the late 1800s, and it was developed further by Pearson. That's why you quite frequently hear it called Pearson's correlation coefficient or Pearson's R. Now, R is the estimate of the true correlation coefficient, which is represented by the Greek letter rho. The value of the correlation coefficient varies between -1 and +1, and in essence it is a measure of the strength of a linear association between two variables. So if you think of a scatter plot or a scatter diagram, you have variable x1 and x2, you plot these individual values, and we're interested in assessing the strength of a linear association. Now, if all of these points plot on a perfectly straight line with some positive slope, whatever that positive slope may be, the correlation coefficient will be 1. Conversely, if all of these points plot on a straight line with a negative slope, then the correlation coefficient will be -1. If you have just a random scatter of data within the scatter plot, then the correlation coefficient is going to be very close to 0. But that's not the only situation where you can get a correlation coefficient of 0. If you imagine the relationship where it has, let's say, a smiley face, something like y equals x squared, if you were to choose points on that line and compute the correlation coefficient using those values, the correlation coefficient is going to be very close to 0, if not 0 itself. Why? Well, because there is no linear association. That's all that the correlation coefficient is measuring. So in practice, we have to be very cautious when using the correlation coefficient. Sometimes we may find instances where people just report the value of the correlation coefficient and have a statement next to it saying R equals 0.013, so no association. No linear association. In practice, we should always have scatter plots, hopefully next to the correlation coefficient, so that we can see whether or not there may be some non-linear association taking place. Notice I'm not saying anything here about cause and effect. I'm just saying, is there or is there not some kind of linear association? What's a good value for a correlation coefficient? Of course, it depends. It depends upon the amount of noise that we expect to see in this system. For example, if you're measuring some kind of a chemical relationship where you know that there should be some linear association between the two variables, and you're doing it in a lab under lab conditions, then there should be a pretty small amount of extraneous variation. So I'd expect your correlation coefficient to be much better, let's say closer to +1 or -1, depending upon the association, than if we're dealing with something like economic data, where there's inherently going to be more noise because we're dealing with the aspects of human beings.